In this podcast number 9, we're going to continue looking at atomic structure and why elements stick together. This is where we left off. We had the periodic table and we looked at group 8, group 7 and group 1 in particular. We said that group 1 essentially has one electron in its outermost orbital. Group 8 has, well, 2 or 8 or 8. Well, we can say that it actually has a full outer orbital. Group 7 here, we can say that elements in group 7 generally have one space available in their outer orbital. So let's move on from there. Let's build some atoms. So element number 1, hydrogen, looks like this. Now I've got a blank here, space for the nucleus, I've got orbitals drawn. Hydrogen is element number 1, so it's going to have one proton. If it's uncharged, it's going to have one electron, and we're going to drop that into the first orbital. Most hydrogen atoms actually have no neutrons at all, so I'm just going to leave that there. So this is hydrogen. That's what we've got. H for hydrogen. Let's build another one. Helium. Helium is element number 2, so helium will have 2 protons. And also, if it's uncharged, 2 electrons. Now the first orbital can hold 2 electrons, so they're going to go straight into the first orbital. Most helium atoms actually also have 2 neutrons, so I'm going to pop those in there too. So that's helium, He for helium. And let's look at lithium. Lithium is element number 3, which means it must have 3 protons. If it didn't have 3 protons, it's not lithium. 1, 2, 3. It must also have 3 electrons if it's uncharged. 1, 2, and 3. Now I can't put that in the first orbital because the first orbital can only hold 2 electrons, so that must go into the next orbital. This orbital, the second orbital, can hold 8. When that's full, then we move on to the next orbital. Lithium, well, lithium can have 2 neutrons, 3 neutrons. I'll put 2 neutrons into this one here. So that's lithium, Li. So time to draw some yourself. I want you to pause the podcast and try drawing in the same way as I've drawn them, sodium and chlorine. Here's a full periodic table that you might need to use to help you. You'll find one of these in your planners as well. Chlorine is up here, element 17, and sodium is up here, element 11. So how did you do? Let's see. I'm going to drag in an orbital here for each side, and we're going to see what we've got. Now we said that sodium was element number 11. Element number 11, so it should have 11 protons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And chlorine, element 17, so we should have 7 protons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now as for the electrons, 11 and 17, if we assume that the atom is uncharged. 1, 2, first orbital. We need to move to the second. 3, 4, 5, 6, 7, 8, 9, 10. That's 8 in the second orbital now. 2 plus 8 is 10. I need to move to the third orbital to put my final and 11th electron in place. Over here, 17. 2 in this one, 8 in this one. 1, 2, 3, 4, 5, 6, 7, 8. So we've got 2 and 8, that's 10, which leaves 7. 1, 2, 3, 4, 5, 6, 7 in the outer orbital. Importantly, for chlorine, it means we have one space. Let's call it an electron space. There is space for an electron. Now this still doesn't answer the question why they stick. Atoms in general feel most stable when they have complete and full outermost orbitals, and that is generally speaking the driving force behind why atoms stick together. Now we can see sodium does not have a full outer orbital. We can see that chlorine also does not have a full outer orbital, but they can team up together to form a compound whereby they both end up having a full outer orbital. So in summary, the atomic number, and hence the position in the periodic table, tells us the number of protons. The atomic number is also the number of electrons, unless the atom has a charge. The group number, the column, tells us the number of electrons in the outer orbital, at least up to element 20. The period number tells us the number of orbitals with electrons. And the number of elements in a period tells you the maximum number of electrons allowed in that orbital. So why do atoms stick together? We're going to talk more about that in the next podcast.